Okay, so in this section, we're going to learn how to prove triangles congruent by the side, side, side postulate. Now, in lesson 2, we learned how to prove triangles congruent by showing that every single side and every single angle was congruent. Now, these next 3 lessons that we're going to learn is you're going to learn specific postulates, and you don't need to show every single piece congruent. So for here, the postulate states that if 3 sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. So here it's postulate 12. It's the 12th postulate you're going to learn. However, memorize it as SSS, or side, side, side postulate. So here, what we're going to do is, if it says triangle DFG is congruent to HJK, we do have to confirm that they do have the same congruency marks that match. So, for example, if we were to match DF, the first 2 letters, with the first 2 letters here, we need to double check that it has the same marking. So DF is here with 2 marks, HJ is here with 2 marks, so that one works out. Then we're going to check 2 more. So FG and JK. So FG is here with 3 and JK here is 3, so far so good. And then you could check the last one, DG to HK. They both have 1. So yes, we could prove that these 2 triangles are congruent by the side, side, side postulate. Next, we got another one to check. This one is ACB. So let's start checking our congruency marks. So AC congruent to CA, well, that's the same middle line here. So yes, it's congruent to itself by the reflexive property. It's the same line on both triangles. Then if we were to check CB and AD, AD has 7 and BC has 7, or CB. So yes, that one works out. So now we're going to check the last one. And if we go from A to B and then C to D, notice AB has 3 and CD has 4. Well, right there, that's failing. So AB is not congruent to CD. So we would say, no, this triangle is not congruent. This congruency statement does not work. Here's another one. Let's check all our congruency marks. So we have QP and RS. QP has 2, RS has 2, that one works. Let's try PT and ST. PT is here with 3, and ST here is with 3, so far so good. And then we'll check the last one, QT to RT. It's here with 1 and 1, so we can say yes, this triangle, this congruency statement is valid, it is true, by the side, side, side postulate. Notice we're not marking any angles here. So as soon as we can show all 3 sides are congruent, we can prove that the triangles are congruent by the side, side, side postulate. Next one. Okay, we need to graph these ordered pairs. And we are going to check out to see if the triangles are congruent after we graph them. So I'll go ahead and graph the first one, the JKL. So J is at the ordered pair -3, -2. Put a dot here. And then I'm going to do 0, -2. And then -3, -8. And that one goes off the graph. But I'm going to connect my dots and make my triangle. Now I'm going to do the other one, the RST. So 10, 0, 10, -3, and 4, 0. Connect the dots, make your triangle. Now, how can we tell if these 2 triangles are congruent from this figure? What do we have to do?
Count the units.
Good. Count the units. We can do that on the vertical and the horizontal sides. So for the blue one, this side right here has a length of 6. And then this one, by counting the squares, it has a length of 3. What about that diagonal side? What do we have to do for it? Perfect. we need to use the distance formula, and we're going to use the order pair, the 4, 0, and we're going to use the 10, negative 3, because we need to know from this point to this point, so the length of this segment, or this side. So I'm going to do the distance formula. Again, it doesn't matter what you use for your x1, y1. So I can go ahead and label this as my x1, y1, x2, y2. And I'm going to subtract the x's. So 4 minus 10 squared plus 0 minus negative 3, which turns it to plus, squared, and it's all under a radical. Negative 6 squared plus 3 squared. Did you get a pass, or are you just coming to school now?
Yeah.
Okay. Because I marked you absent, so you went to student services?
Yeah.
Okay, perfect. Okay, so we're going to finish this up, and we get 36 plus 9, 45. Now, right now at this point, if this were a question like just a distance question, you would have to break down that radical. However, if we're just trying to see if the sides are congruent, we can leave it the square root 45. But I'll go ahead and break it down. It'll factor to 9 times 5, and then it becomes 3 radical 5. I now have to check the red triangle. Okay, we can see that this is a 3 by counting the squares, and this is 6. I now have to do the distance formula between this point and this point, which is going to be the order pair, the 0, negative 2, and the negative 3, 8. So x2, y2. I now have to do the distance. So I'm going to do negative 3 minus 0 squared plus negative 8 minus negative 2, which makes it plus, under the radical. So negative 3 squared plus negative 6 squared, still under the radical. 9 plus 36. Notice I'm getting the same number again, square root 45. So I can already see that the 3 sides are congruent. And again, you'd have to, show the congruency statement and show that JK is congruent to RS, and that KL is congruent to ST, and that JL is congruent to RT. So because you can show that all 3 sides are congruent, you can prove that these 2 triangles are congruent again by the side, side, side postulate. So we don't even have to involve the angles. Yes?
2 sides are congruent on triangles, and the right side always going to be congruent.
Not necessarily. I guess yes, it usually will, but you're going to still have to prove it. And you would have to show the lengths. When you did the Pythagorean theorem, yes, you're going to get the same number. However, you still got to do the distance formula and show it. Yes. You got to take it that extra step. All right, our last slide. And this is a real world example, and it wants us to explain why the bench with the diagonal support is stable while the one without the support can collapse. Anybody have any ideas here? Hayden?
Because if the third person sits on the one that doesn't have a third one,
Right, it could collapse, right? It could cave in. So by providing and creating 2 congruent triangles here, the stacking 2 congruent triangles on top of each other is going to make this bench more stable. So providing more structure so it's not going to collapse. So as soon as we can put in there 2 congruent triangles, it's going to make that bench more stable. So that is the entire lesson. All you need to do is show that all 3 sides are congruent. If you can show that all 3 sides are congruent, that makes the 2 triangles congruent. Your homework over the weekend is the practice B. On Monday, we will learn the next one. Tuesday, another one. Wednesday, we're reviewing, and we will have a quiz. on these new postulates that we're going to learn on Thursday. All right, so that is the lesson. You can go ahead and start your homework, and if you have questions, you can let me know.